Why this table? This is the Kerfel and Essa version of the pocket transit invented in 1894 by the mining engineer D.W. Brunton. It was designed to be as useful and flexible as a pocket instrument could be. There was room for one small math table on the back, and the table of natural sines was selected. Brunton must have thought this was the most important table. I agree. For a right triangle, with sides A, B, and H being the long side or hypotenuse, all you really need are three formulas. A equals 90 minus B, since one angle is 90 degrees and the total is 180. A squared plus B squared equals H squared. And the sine of angle A is A divided by H. Given one angle and one side in a right triangle, the sine function can give all the sides. So now the sine function has tamed the right triangle. For most purposes, right triangles and the associated rectangles are all we use. Other triangles crop up often, however, especially in surveying. The sine function can tame them as well. Here is a non-right triangle. By drawing a right angle line from a side to one corner, the triangle is divided into two right angles with side O common to both. Here are the sines of the two angles. Here we relate the two sine formulas by the common side O. This formula is called the law of sines. Here it is in the traditional form. The sine of an angle divided by the opposite side is a constant for any triangle. Measure the angles of a triangle and one side, and you have all the sides from the sine law. Here's how to use the sine law. To start, divide a known side by the sine of its opposite angle, obtaining the constant factor for the triangle. To find a side, multiply this factor by the sine of the opposite angle. To find the sine of an angle, divide the opposite side by the factor. If you only know one thing about triangles, the sine law is the one thing. A quick, no sine needed estimate, by the way, can be had by dividing a short side by its opposite angle and multiplying by 57.3. If the angle is less than about 5 degrees, this gives the average length of the two long sides to good accuracy. I hope this tames the triangles for you. And thanks.